Hello guys, welcome to tutorial 2 and the node voltage method. And in this video we are going to use the method to calculate the current through each of the resistor. So we have to first of all identify the number of nodes and then assign voltages to them. So I have a node here, so let's say the voltage here is V1. I have another node here, the voltage here is what? V2. And I have my third node, which is what? Down there. So the down here, the portion here, I can consider all of this as a single node. That is, I can connect the branches at the bottom here. I can connect all of them to form what? A single node. Pull this branch here, pull this branch to this junction, and what? Add this branch also that junction. So I'll form a node here, and I'll assign voltage what? V3 to that node. So after assigning voltages to the nodes, we have to set one of the voltages or one of the nodes to be the reference. So preferably we are using the bottom node, or you can use the node with what? The maximum number of branches. This node has 3 branches, this node has 3 branches, this node has what? 4 branches. So this qualifies to be our reference. And since it is the reference node, it means the voltage is what? 0. So we know that V3 is 0 volts. So we now proceed to write KCL at the non-reference node. That is KCL at node 1, and we also write KCL at what? Node 2, because those two are unknown. So we are going to write KCL then. So let's start with KCL at node 1. So what is the KCL at node 1? I1 entering is equal to what? I2 plus I3. So the next thing to do is to express each of the currents in terms of its node voltages. So as we did in our previous video, I1 is starting from a node. That is the reference, okay? Let's say it is starting from there to V1. So it is starting from V3. It means V3 minus the node that it is going, which is what? V1. But on its branch, it met another what? Voltage there. And the I1 is from here. So I1 is on this branch. It will leave the positive of this voltage, so it means you have to add that voltage. So plus 20, then we divide by what? The resistor on that branch, which is what? 50. Is equal to what is I2? I2 is starting from node V1 all the way to what? The reference node. So we have V1 minus V3. But on its branch, it met another voltage, which is what? 5 volts. But the I2 will leave the negative of that voltage, so minus 5 over what? The resistor on that branch, which is 20. So we have plus I3, and I3 is where this current. It is starting from node V1 to where? Node V2. So I have V1 minus what? V2. But on its path, it met another voltage, that is 5 volts, and that current will leave the positive of this voltage, so plus 5 over what? The resistor on that branch, which is what? 40. So now we can what? We can find the LCM here, but don't forget that our V3 is 0 volts. So let's simplify this equation. We have V3 to be 0, so this place becomes 20 minus V1 over what? 50 is equal to what? V1 minus 5 over what? 20 plus V1 minus V2 plus 5 over what? 40. So let's calculate for our LCM. Our LCM is what? From here, our LCM can be 200. So let's multiply this place by 200. The 50 will go into the 200. You have 4. So 4 multiplying 20 minus V1. 200 multiplying this one will get what? 10. We have 10 multiplying V1 minus 5 plus 200 multiplying this one, we can get what? We can get 5. So 5 multiplying V1 minus V2 plus what? 5. So let's expand the brackets. We have 4 by 20 giving us 80 minus 4 V1. We come here, is equal to 10 by V1. I have 10 V1 minus 50 we come here. This one gives us plus 5v1 minus 5v2 plus 25. So we can group our like terms from here. So I have 80 plus 50 minus 25 is giving us what? 10v1 plus 5v1 plus 4v1 is giving us 19v1 minus 5v2. We are just simplifying this equation. So what do we have here? We have 19v1 minus 5v2 is giving us what? We have 80 plus 50 minus 25. That is 105. So this can be our first equation. Alright, after evaluating our first node, this is what the equation we are having. So we will proceed to our second node and write the KCL at that node. So we have KCL at node 2. And at node 2, what's the KCL? We have I3 is entering, I5 is what? Entering, I4 is what? Leaving. So I3 plus I5 is equal to what? I4. Then we are going to express the current in terms of the node voltages. We've already done for I3 in the first node. So I3 is what? V1 minus what? V2 plus 5 over what? 40. Plus we move to I5. I5 can simply be what? 30 minus what? V2, because we know our V3 is what? 0. So we can simply say our I5 is what? 30 minus V2 over what? The resistor 80 is equal to I4. I4 is starting from what? V2 to what? V3, which is 0. So it can simply be what? V2 minus 0 over 10, which is the same as V2 over what? 10. Because I know V3 is what? 0. So what is the LCM here? We can use 80 as the LCM. So let's multiply here by 80. We have what? 2 V1 minus V2 plus 5 plus 30 minus V2 is equal to what? 8 V2. Multiplying through by what? 80. So let's expand. We have 2 V1 minus 2 V2 plus 10 plus 30 minus V2 is equal to 8 V2. So let's do the like terms. I have 2 V1, V2, V2, V2. Let's bring the V2 to this side. What do we have? Minus 2 minus 1 minus 8 gives us minus 11 what? V2 is equal to 30, 10 plus 30, giving us what? Minus what? 40. So this becomes what? Equation 2. So we have equation 1, we have what? Equation 2. And the variables are V1 and what? V2. So we can solve these two simultaneously and get our node voltages V1 and V2. So let's solve it together. So I'm using the calculator to punch. So I have my first equation, 19 minus 5, 105. I have my next equation, 2 minus 11 minus what? 40. So my V1 is equal to 6.809 volts. That's my load voltage, V1. And my V2 is giving me 4.874 volts. So these are my node voltages. But the question is asking us to find what? The branch current. That is I1 through to what? I5. So we can do that one because we know the formula for each of them. We know that I1 is equal to what? 20 minus V1 over 50. So you know that V1 is also what? 6.809. So you just have to substitute your V1 here. So I can point for the first one. Our I1, let me do for the I1 here. Our I1 is what? 20 minus what? V1, which is 6.809 over what? Resistor 50. So my I1 gives me 20 minus 6.809 over 50, which is equal to 0.2638 amperes. So current I1 is equal to this. So you can do the same thing for what? I2. I2 is what? V1 minus 5 over 20. Substitute your V1, get your I2. Your I3 is what? V1 minus the V2 plus 5 over 40. Do your substitution here, you get your I3 value. You proceed to I4. We know I4 is what? V2 over 10. That is what? 4.874 over 10. That will give you your I4. And your I5 is what? 30 minus V2 over 80. Substitute your V2 here, and that one will give you your what? I5 value. So this is the solution to this question using the node voltage method. Thank you very much for watching this video.